Now remember, we'll have a quiz on Friday over the factoring methods that we've learned so far. So we've done factor out of greatest common factor. We've done factor by grouping. We've done factoring for trinomials when we have a leading coefficient of 1. And we've done AC method when they don't have a leading coefficient of 1, right? We did AC method last time. Let's do a few more examples together. Make sure that we're all on the same page with the AC method. And then we will get into a new topic today. And we'll finish that topic off on Friday before your quiz. But that particular topic won't be on your quiz. Okay, so just these few that we're going to do, practice again, make sure we're all on the same page with the AC method. That's where your quiz will stop. Okay, so everything that we've done with factoring up until that point. Right. So even though we're going to learn something new today, that won't be on Friday's quiz. Okay? All right. So this is on the back side of the sheet that we did last time. So let's look at a few of these. Like I said, I just want to make sure that we're all on the same page with doing these. Work on it together for here in a second. Let's look at the first one. Again, anytime you come across a factoring problem, what's the very first thing you should look for? A GCF, right? Do we have any GCF to factor out in this one? In particular, that 19 is only divisible by 1 or 19, right? Nothing else goes into it evenly. So the GCF there is going to be a 1. All right, so we don't need to worry about anything for a GCF. But let's look at now how we do AC method again. What do we do to start AC method? What do we do first? Yeah, multiply the 6 and the 15. So first thing we do is 15 times 6 gives us 90. That's first step, right? They take your leading coefficient, a coefficient on the x squared, and multiply it by the constant. That's for step 1. What do we do next? Yeah, factors of 90, right? Let's do that next. So certainly 1 and 90 go together. What else? 2 and 45. What else? No, always use a calculator, right? So check if 1 goes into it. Oh, well, actually, 1 always goes into it. Check if 2 goes into it. Does 3 go into it? Does 3 go into 90? Yeah, so it'd be 3 and 30. 4 doesn't go into it. 5 does. 18, good. 6 does, clearly, because we just did 6 and 15. 7 doesn't go into it. 8 doesn't go into it, but 9 does. 9 and 10 work. Right? And then we know we're done, right? Because we tried 1, 2, 3, 4, 5, 6, 7, 8, 9, but 10's already paired up with it. All right, so now we know we're done when we get to that point. And again, if you need to use your calculator, that's fine. Again, just start with those 2 go into it, those 3 go into it, and find those pairs, right? And you'll know if it goes into it or not if a decimal part comes out that doesn't go into it. So you don't have to sit and try to remember all your multiplication facts. You can always use your calculator to help with that. Be very, very systematic about it. All right, so again, now what's the next step to try to figure out? What do we use these factors for? Yeah, trying to get the negative 19, right? We're trying to get the number in the middle. Just to remind again, that plus sign right here tells you that both signs have to be the same. And since it's minus, they both have to be negative, right? So what do I need to use to get negative 19 then? Now the 9 and 10 and make them both negative, right? Negative 9 and negative 10. All right, so what do we do with that now? How do we use the 9 and the 10? What do we do? Oops, it's a 19. Good. We rewrite that one in the middle as minus 10x and minus 9x, right? And then what do we do? Well, what technique do we use to factor that one now? The grouping, right? Good. So looking at the first two, looking at just those two, what can you factor out? A 2 and what else comes out? An x. Good. Right? 6 and 10 have a 2 in common. X squared and x have an x in common. So 2x can come out. What are we left with in the first term? It's not 4. I think it's 3, isn't it? We divide it by 2. And then minus 5. Good. All right, when we pull out the x, we're left with 1 here. We have none there. Pull out the 2. Remember, we're dividing by the 2, right? 6 divided by the 2 makes the 3. 10 divided by the 2 makes the 5. What are we looking for in the second set then also? Got a 3x minus 5 in the first set, so we need a 3x minus 5 in the second set, don't we? Okay. That was weird. What can we factor out of the second one? Yeah, there's a 3 in both of them, right? But notice if I don't take the negative sign out as well, I'm not going to get a positive 3x, right? So I need to factor out a negative 3. That'll leave a 3x here. We pulled out the minus sign. So what does that change that plus sign to? A negative. And we'll get 3x minus 5. And isn't that what we wanted? Because now how do we finish this off now? What's the last step? Three x minus 5 times the 2x minus 3. Good. Now we'll pull out that whole 3x minus 5 piece. All right, let's do the next one here together. Again, looking at this next one, part B here. What do we look for first? Always? It's always the first thing you look for? GCF. That has to be first, right? Every single time, look for a GCF. Okay? Looking at the 6, the 4, and the 16, what do those all have in common? A 2. I've got an x cubed, an x squared, and an x, so what else can we... Oh, somebody left their phone. That's not good. Oh, somebody's trying to find their phone. That's what that is. All right. Don't know whose phone that is. I wonder if it's the person who taught in here before this class. But anyway, looking at the x cubed, the x squared, and the x, I didn't even know it was there. It's a nice surprise. What can you factor out for the x's? An x, right? Because there's an x at every single term. When you pull out the 2x, what are you left with? 3x squared plus 2x minus 8, right? We pulled out a single x, so it's x squared and x, and then we pulled that one out, so there's not an x anymore. Pulling out the 2 means we're dividing each of those by 2, right? So 6 divided by the 2 is a 3. 4 divided by 2 is 2. 16 divided by 2 is 8. All right, so now we've pulled out the 2x, so all we're interested in now is this piece. What do we do next? 3 times a negative 8, and look for those factors, right? So we'll do that off to the side here. 3 times negative 8 gives us negative 24. What multiplies together to give you 24? Nothing? Nothing multiplies together to give you 24? Okay. What works? 1 and 24, what else? 2 and 12, what else? 3 and 8, and 4 and 6. And then we're done because 5 doesn't go into it, right? And we've already got 6 taken care of, paired up. All right. It's a negative 24 when we multiplied, right? That sign on the 8 is negative. When that sign is negative, when the sign on the constant term is negative, what does that tell you? One is negative and one is positive, right? So looking at your factors, making one negative and one positive, what number do we need to come up with? What number are we trying to get? The 2, right? Good. Trying to get the 2. How are we going to get 2 out of those factors? The negative 4 and positive 6 is a positive 2, right? So we'll use negative 4 and positive 6. And again, what do we do with those? Oh, is this what you're looking for? Yep, I heard it go off.
Thank you.
Yep, there you go. Well, at least you found it. Yeah. Say it again. Yeah, maybe replace the 2x with what? Yeah, good. Do the 6x and the negative 4x, right? Does it matter what order you put them in? Could you have also done negative 4x plus 6x? Does that matter? Nope, doesn't matter. You can do it either way. Okay? You can't, as long as you have the right numbers here, it doesn't matter what order you put them in. Okay? I can do negative 4x plus 6x or 6x minus 4x. Either way works. Okay? What do we do next? How do we factor that big chunk now? So yeah, we factor this part and factor that part, right? What do we factor out of the first 2 terms? So what can we factor out of the 3x squared and the 6x? What do the 3 and 6 have in common? A 3. And what do the x squared and the x have in common? X. What are you left with when you factor out 3x then? X plus 2. Yep. All right, we took a 3x out, right? So the 3 came out. 3 divided by 3 is 1. We took out 1x, there's still 1 left, right? So what do we want to see when we try to factor something out of the second 2 terms? What do we need to see? The same thing as we have here, right? I need to see the same exact thing. What do I need to factor out then for the second 2 terms to see the exact same thing? And certainly there's a GCF of 4, but we also need to factor out the negative, right? Because remember, when we pull out the negative, it'll pull it out the negative here as well. It flips the sign. We're left with x plus 2. And then finally, what's the last step here? Not everybody at once. What do we do next? So it's, what is it? Yep. And the 3x minus 4? Good. Do we want to do one more? Or are we okay? We okay? Or you want to do one more? One more? All right, we'll do one more. Okay. Let's look at, it doesn't really matter which one. Let's look at part D there. Again, first thing you should always look for is what? The greatest common factor, right? So always step one. Do you see something that they all have in common? A 3, right? 3 goes into 30, 3 goes into 57, 3 goes into 18. So we can pull out a 3. When you divide the 30 by 3, you get 10. When you divide the 57 by 3, you get 19. And when you divide the 18 by 3, you get 6. Good. Remember, that's always your first step is to factor out the GCF, right? Get that greatest common factor out. What's the next step? 10 times the 6. Good. Take your leading coefficient times your constant. 10 times 6 is 60. So again, we're going to look for factors of 60. Well, 1 and 60 certainly works. Does 2 go into 60? Get 30. Good. Does 3 go into 60? 20. Does 4 go into 60? I think it's 15, right? 5 goes into it 12 times. 6 goes into it 10 times. 7, 8, and 9 don't go in evenly. So we're done. So far, so good? All right. How do we use those factors? What are we trying to find now? We need to find 19. And it says it's a plus 6 and a plus 19. We're going to make sure both numbers are positive, right? So what do we need to choose to get us 19? The 4 and the 15, right? That's going to give us the 19. So we'll rewrite the 19x as what? Positive 4x and positive 15x. Good. Exactly right. Yep, that's exactly right. And now we do the factor by grouping bit. Oops. Looking at the first two terms, what can you factor out? A 2 and an x. Factor out 2x, you're left with 5x plus 2. Good. Out of the second 2, we can factor out a 3, and we're left with, better be what? It better be 5x plus 2, or we've messed something up along the way, right? Remember, the whole point of this is that I want to see the same binomial in each group of 2, because I'm going to factor out that binomial. So finally, then, what do we get? 3 times 5x plus 2 times 2x plus 3. Good. Questions on that one? All right. Well, I'll leave the rest of these for practice. If you got questions about it, of course, you can always come ask me. Go to the Math Center. They can help you out with them. Go to the professional tutor. Professor R Time has hours tomorrow from 3:30 to 5. If you want to see her outside the Math Center hours, come see me. Go see the SI. The SI hours are up on Google as well. I believe he has both a review session and office hours tomorrow as well. So again, remember we're having a quiz over the factoring methods that we've learned so far on Friday. So this stuff that we're going to talk about now, this is the new stuff. This won't be on Friday's quiz. Fingers at work. It'll just be a factoring quiz. Yeah. The previous quiz was the adding, subtracting, multiplying. This will just be a factoring quiz. See any trees up there? Need intermission music or something playing while I hand out these papers. All right. Let's go ahead and talk about the new stuff. Where it talks about what we refer to as special forms. So, before we go through the notes real quick, let me just look at the page of the practice problems that I handed out. I'm not going to do them right this second. I just want you to look at them. Notice that these practice problems are different than ones we've had before, right? In particular, in the last section when we were doing factoring, how many terms did the polynomials have? 3, right? When we did factoring by grouping, how many terms did the polynomials have? 4, right? These all have 2 terms, right? So something different is going on, right? We haven't talked about trying to break up 2-term polynomials into binomials at all, okay? So it's a different form that we're going to use to get these factored if we can factor them. Sometimes you come across things that can't be factored. Okay, so that's why we're calling them special forms. They have very special formats based on the way things multiply. All right, so let's look at this part right here, this where it was in your notes. Notice that we can show that these 2 things are equal by multiplying out the right-hand side. Let's just practice that. We've talked about that before. Remember, when you multiply this out, we have to make sure we distribute everything, pardon me, everything in the first polynomial to everything in the second polynomial, right? So we get x times x gives us x squared, right? X times negative 5 gives us negative 5x. 5 times x gives us plus 5x. 5 times negative 5 gives us negative 25. That's how we would distribute that, right? We agree? We've done that previous? That was actually on the last quiz stuff, right? What happens right here in the middle? What happens to a minus 5x and the plus 5x? They cancel each other out, and we end up with x squared minus 25, which is what it says there, right? So notice that, look at this factorization here. Notice these 2 things these 2 factors look almost the same. The only thing that's different is the sign in the middle, right? And notice that sign in the middle is what's making these things cancel each other out, right? Because we got a minus 5x and a plus 5x. When we have this situation where we've got x squared and 25 like this. We refer to this as a difference of squares. And that's what the title of this section is the difference of squares. Notice that we have an x squared. 25 is the same thing as 5 squared. That's what we mean by difference of squares. Okay? That's why I handed out that other sheet that's got all of those perfect squares in there. We need to be able to recognize those. So those gives you the squares from 1 to 12. So we can recognize them. So notice that the formula looks like this. This is your difference of squares formula right here. The a squared minus b squared. So let's see if we can put that to use before looking at the next for the difference of cubes. Let's scroll down here to this number 1 that's on the back side. I want to do a practice at least with one of these with difference of squares, and then we'll talk about the cubes. Okay? All right, so anytime you see a two-termed polynomial like this, and you're being asked to factor, it's going to probably be one of these special forms. Okay? Now notice that in this case we have a difference, right? So it's going to be one of our difference formulas probably. And notice we have an x squared, so it's probably going to fit that. If it's going to factor, it's probably going to fit that difference of squares, right? So your difference of squares, again, the formula I'm going to write it at the top of the page here. It looks like a plus b times a minus b. So the first thing I'm going to do is I'm going to look at the individual terms and see if I can write them as a perfect square, as something squared, okay? Let's do the 25 first because I think it's a little bit easier. What number squared gives you 25? 5, right? So I can rewrite this as minus 5 squared, right? I'm going to do the first term here in a second, but looking at this, the way this is written, this is the minus piece. Looking at the formula, what do you think you're going to use for the b? What's been plugged in? If you look at it this way, what's been plugged in for b? 5, right? So that's going to be our b. Okay? If it's going to be a difference of squares, I need something squared for that first term as well. This one's a little bit different. What do I square? Let's ignore the 4 for the time being. What do you square to get x squared? X, right? Now let's do the 4. What do you square to get 4? 2. So I can think of 4x squared as 2x the whole thing quantity squared. You just told me that this 5 is your b, right? Because that's the thing that's squared. What do you think is going to be your a? The whole 2x piece, right? This whole thing is going to be your a. Because I have a, 2x, a is squared, and then the 5, the b squared. Okay? So using the formula, if I have a squared minus b squared, we'll do it as a plus b and a minus b. Well, the 2x is playing the role of the a, and the 5 is playing the role of b. So we get 2x plus 5. What's the other factor then? 2x minus 5. Good. That was weird. That's okay? Let's do one more. We're going to do more practice like this, but let's do the number 4 at the bottom. And then we're going to talk about the difference of sum and difference of cubes. Look at number 4. Again, anytime you come across a factoring problem, the first thing you look for is a GCF, right? What do those two terms have in common? They're both divisible by 2, and there's also an A in there, right? I can divide both of them by 2. They both have a factor of 2, and they both have an A. So if you factor out 2A, what are you left with in the first term? 4x squared, and in the second term you're left with 49. We okay with getting that common factor out? Yeah? Okay. Notice it has an x squared. So if it's going to factor, we're going to use that difference of squares formula. If it's going to factor, it's going to be a difference of squares because I have an x squared here, right? So again, I want to try to rewrite it like we did the other one. Let's do the easier part. At least I think is the easier part first. What number squared gives you 49? 7. So I can write the 49 as 7 squared. Does that make sense? And again, that's why I gave you that sheet, right? So you can see if you've got the square, what gives it, what is the square root of that number essentially. Now this one looks exactly like what we did in the previous one, right? But let's think again about how we wrote that. I need a whole thing squared, right? I need to figure out what the A piece is. Well, to get x squared, I have to have an x. To get 4, what needs to be squared? 2, right? So we get that 2x on the inside again. So the 2x is the A, the 7 is the B. So how does that part factor then? Good. So again, remember you've got your, I'll just write it down here since that's off the screen. You should have it in your paper. Right? This part is my A, this part is my B. So I'm just plugging it into the formula, right? A is 2x, B is 7. Yes, fine. It may not have a variable, it might be flip-flopped. The variable might be in the second case. Say it again? There should always be a variable somewhere, yeah. But it might be flipped around, but there should always be a variable somewhere. This example okay? So let's do, we didn't do those two on purpose because we haven't talked about the formulas yet. So let's scroll back up here or flip your paper back over, as the case may be. The other two special forms have to do with cubes. Notice we just did a squared minus b squared. Let's do difference of cubes. A cubed minus b cubed. To figure out how that has to factor, let's do the distribution here that's given to you on the paper here to see how it factors. So remember, if I'm going to multiply these two things together, we need to take the first and distribute it to everything, and then take the second and distribute it to everything, right? When you multiply the A times everything, what do you get? Let's do the A times everything first. What do you get when you run the A through? You get an A cubed. What else do we get? A squared B and AB squared. Good. I'm just taking the A times everything, right? Is that the only distribution we have to do? No, we also have to do the minus B, right? So now take the minus B and multiply it by everything. What do you get there? You got the negative B times A squared will give us negative A squared B, right? What do you get when you take negative B times AB? Minus AB squared. And then finally, when you take the negative B times B squared, what do you get? Minus B cubed. Do you see anything that goes away? Do you see anything that matches with this? Yeah, I got to minus that, don't I? So that just is going to cancel, isn't it? How about this one? Those cancel as well, all right? These are going to go away. These are going to go away. And the only thing we're left with is a cubed minus b cubed. So this is the formula we're going to use to factor a cubed minus b cubed. We need to recognize something cubed minus something else cubed. So let's look at the example we have here. The 8x cubed minus y cubed. Well, certainly y cubed is already a perfect cube, right? Okay. But let's look at the first term and split it up like we were doing with the squares, right? What do you need to cube to get 8? 2, right? That's again why I gave you the sheet, isn't it? Okay. So what goes in the parentheses here then? 2x, right? So a 2x, the whole thing cubed, gives us 8x cubed. All right, so look at your formula here, and I'm going to rewrite the formula so it looks a little bit nicer. What's playing the role of A? The 2x is what's in the parentheses here, right? This is your A. What's playing the role of the B? The y. Just the y. So using the formula then, what do we get? We get 2. You get a 2x, right? But remember, the cubed is on this side. The A part is just the 2x. So it's 2x minus y, right? And then it's 2x squared plus 2x times y plus y squared. Again, just to write it on top here, here's your A. Here's your A squared. Here's your AB. Here's your B squared. We're going to do more examples of this, but let's just make sure we go through and see the pieces. Notice that the sign in the middle here is the same as the sign in the middle here. This is the opposite here, right? It's a minus and a plus in the middle here. Okay. One nice thing about doing this particular formula, even though this gives you a quadratic, an x squared and a y squared, you don't ever have to worry about factoring this one. This never factors. Okay. This one will never, you can just stop here at this point and it never factors. I will simplify it a little bit. Two x, the whole thing squared, is 4x squared. And then I can write the rest of it as 2xy plus y squared. I just simplified the 2x, the whole thing squared. The reason I mentioned the bit about there's a minus here and a plus here, notice in the next formula where you've got a sum of two cubes, notice this sign matches here. This one is the opposite, right? It flips in the middle. So when you're doing a sum or a difference of cubes, the sign in the middle is opposite. from one factor to the next. Okay. All right, so let's see if we can apply these to the examples that we have on here. I'm going to rewrite it on the top of my page here. A cubed minus B cubed is A minus B times A squared plus AB plus B squared. And then opposite sign in the middle for the other. All right, so first, do you see why we might use a cube formula here rather than a squared formula here? What's giving you your big clue that you might want to use a cube formula? You get an x cubed, right? I've got an x cubed and a y cubed, right? So that's telling me I probably want to use a cube formula. Okay? Which one of those do you think I want to use? A difference or the sum? Difference, because I have a minus sign in the middle, right? So again, just like your difference of squares formula, I need to identify your A and your B. What do you cube to get 64? 4. What do you cube to get 27? 3. So what's going to go inside the first set of parentheses? 4x, good. Now what's going to go inside the second set of parentheses? 3y, good. So what's playing the role of A? 4x and the B? 3y. Good. So this whole 4x is the A, this whole 3y is the B. So again, this is your A, this is your B. So we want to use, again, this formula right here, that cubes formula. What's the first factor going to be? Yeah, good. 4x minus 3y. Fantastic, right? It's the inside of what those parentheses are, right? It's the things being cubed. It's just 4x minus 3y for the first one. In the second one, in the second piece, that first term, we square the A, right? I'm going to write it with parentheses to start with. You're going to square the A. So I'll write it as 4x, the whole thing squared. What's the next term? Is it a minus or a plus? Plus, what's A? 4x. What's B? 3y. I'll simplify it in a second. I'm literally just plugging into the formula, right? We know that the A is the 4x, so we plugged it in. We know the B is the 3y, we plugged it in. And the last piece is going to be what? Yeah, the B squared, right? So it's the whole 3y squared. So again, all I'm doing is identifying the A, identifying the B. I'm taking out the A and putting the 4x in it, right? I'm taking out the B and putting a 3y in. Now we can simplify a little bit. Four squared is 16, so we get 16x squared. 4 times 3 is 12, so we get 12xy. 3 squared is 9, so we get 9y squared. Okay. Again, the big thing to remember, besides the formula, the big thing to remember is the sign in the middle flips. Okay. So let's see if we can do the sum of two cubes formula. Let's look at that number 3. I'm going to rewrite the formula up here so I can reference it. little bit trickier, but I think we can get through it. First off, what about the problem tells you it's a cube formula probably rather than a square? I say an x cubed, right? Okay. This is probably your big hint that you want to. It's two terms. If it's a two-term polynomial, it's going to be one of these three formulas that we've learned today, or you can't factor it. Okay. The fact that it says a cube rather than a square tells me it's probably a cube. And since there's a plus sign in the middle, it's going to be a sum of cubes. Yeah. Okay. So I want to write this as something cubed plus something else cubed. The second piece is a little tricky. I think we can get through it, but let's do the first piece. What do you cube to get 8? 2. What do you cube to get x cubed? X. Good. Yeah, that was not a trick question, right? I cube x to get x cubed. Okay. Second piece, a little tricky, but I think we can get there. 125. What do you cube to get 125? 5. Good. The next part's a little bit harder. Not too bad, but a little bit harder. It's a little bit trickier. I got y to the 6th. What do I have to multiply by itself 3 times to get a 6th power? Y squared, right? I got to have 2 y's times another 2 y's, another 2 y's, right? So I got to do a y squared here. I need to figure out what I have to figure out. What do I need to multiply by itself 3 times to get up to the y to the 6th? All right, so what's playing the role of a now? 2x. What's playing the role of b? 5y squared. There's your b. All right, so now using our formula, what are we going to get for that first p, that first factor? Yeah, 2x plus 5y squared. Good. It's the a plus the b. What's going to be the first term in the second factor? 2x, the whole thing, squared, right? Is it a plus or a minus for that middle term? Minus. Remember, it's always the opposite sign. Minus what in this case? 2x times 5y squared. Good. Multiply together, right? It's a times the b. And then finally, the last one's going to be 5y squared, the whole thing squared, right? Remember here it says take the a and square it. Take the a times the b. Take the b and square it. And then we can simplify a little bit. 2 squared is, yeah, so we get 4x squared. Good. 2 squared is 4. 2 times 5 is 10, so we get 10xy squared. 5 squared is 25. Y squared is y to the 4th. Good. Because it's y squared times y squared. Remember, we add the exponents in that case, right? 2 plus 2 would give us the 4. All right. So for Friday, you've got the extra sheet of practice problems there. If you want to practice on them, good. We will go through practice problems on Friday together on these special forms. And then the last half of class, you'll have your quiz. Your quiz is going to be 6 factoring problems. That is the whole quiz. Okay? Remember those forms again: GCF, grouping, trinomials of leading coefficient 1, and then AC method when it doesn't have a leading coefficient of 1. Okay, so nothing tricky, these 6 problems. Okay, have a good one. We'll see you on Friday.